Hi there, great teens. All right, so before we do any of the examples and learning some new concepts, let's just get a little bit of a bigger picture of what is trig. What are we actually doing? So, trigonometry means that it is the measuring of triangles. We are going to be measuring angles and sides of triangles. It is built on the idea of similarity, similar triangles, and it's all about the ratios of sides. Okay, why is it relevant to us? Why are we going to use it in grade 10? So think about this. At this stage, you've learned the theorem of Pythagoras in order to help you find a missing side, right? So if I give you that side length over there is 4 and that side length over there is 5, then using the theorem of Pythagoras, you'll be able to find the third missing side. All right, so we've got the theorem of Pythagoras to find a missing side when we are given two sides in a 90-degree triangle. And also to find missing angles. What have we got to find missing angles? The sum of angles of a triangle adds up to 180. So when we've got two given angles in a triangle, we can find the size of the third angle by using the sum of angles of a triangle. Now, what trig is going to help us with is that now when we are given some angles, one angle, and a side, we will be able to find another angle. Or if we are given an angle on one side, we can use that information to find another side. If we got given two sides, we'll be able to find a missing angle. So we are now in a position where we can find angles and sides if we got given angles and sides, which you haven't been able to do at this stage. So that just opens up this whole new world of what we can do with triangles. Now, let's just quickly make sense of how we label these triangles so that we know that we're talking about the same things. And then we're just going to define our trig ratios. And then we're going to have a little squiz at where it is used in the real world. So let's just quickly label these triangles. So if I position myself there, and in the first video, we said that we're going to use some new symbols in this section. Hey, we're going to use some letters from the Greek alphabet. That is our theta in this case. So that means that I am positioned at that angle theta, whatever its size is. So then opposite the 90-degree angle is always our longest side, your hypotenuse. And then opposite this angle is opposite side, and adjacent next to that angle theta, that would be our adjacent side. If I change my position, let's say I go and put myself by that other angle over there. Let's say over there. Let's say now theta is there. Then, well, this stays the hypotenuse opposite the 90-degree angle. Now this side is opposite and that side is adjacent. So very important. Let's do one more. So if I am there, angle theta, opposite the 90-degree angle, there's my hypotenuse. The side opposite the theta, angle theta, is my opposite side, and then that would be my adjacent side. All right, let's go and define some trig ratios. Okay, for now, forget about sine and cos and tan. If you've been introduced to that, let's just quickly have a look at where that comes from. So over here, I've got three similar triangles. Because I know that they are similar because that I've got an angle of 30, 30, 30 in each, meaning that that other angle would be 60, right? Because of sum of angles of a triangle. And for similar triangles, the angles all need to be the same. Now, if I look at triangle 1 over there, if I look at the ratio of my sides, and remember, there were people back in the day, centuries ago, who dedicated their lives to mathematics and finding the patterns and coming up with theorems, and not just for fun. I'm sure they did enjoy it, but not just for fun or to make our lives harder, because I know a lot of you don't see the purpose of why you need to learn this, but they had real problems in their lives. They had to find ways of building these structures and finding ways to get from point A to B with navigation. They wanted to figure out the distance between where they live and I don't know where they wanted to go. And they had to find ways to measure that and to make it happen. All right. If I look at this triangle and I am there by 30 degrees and I take the opposite side, the one, and I divide it by the 2. It means that the ratio between the opposite over the hypotenuse is equal to A half. Okay, then I go to my triangle that is similar to it. And again, I go look for a pattern. I see if I take the opposite and I divide it by the hypotenuse, it is 3/6. And again, for the last triangle, I take the opposite over hypotenuse because I'm by 30 degrees every single time. If we simplify this, we get a half and we get a half. So what can we gather from that? For these triangles, if my angle is 30, the ratio of the opposite over hypotenuse is equal to a half every single time. How can we use that? Now, if we make another similar triangle that is similar to this one, even if it is huge, we know that the ratio between the opposite and the hypotenuse will remain constant and it will be a half. So then they were like, okay, we need a name for this. And this is also how it's programmed into your calculator. So let me just first put it in words and then we'll write it in a mathematical way. If a right angle triangle, so right angle meaning a 90-degree triangle, has another angle of 30 degrees, you will always get that the opposite divided by the hypotenuse is equal to a half. If we change the angle, obviously the ratio will change, but it will always stay consistent. What do I mean? Let me just write that down as well. If we change this angle to 50, the opposite over hypotenuse will still remain consistent, even if we make the triangle bigger. The opposite over hypotenuse will still have the same ratio. Let's do it for cos as well. And that's where the name sine comes in. So what we just said in words, we can now write it in a mathematical way. So the sine of 30 degrees will always be equal to 1/2. So the name for dividing the opposite by the hypotenuse is sine. That's naming the ratio. All right, if we do it for cos, if I take my adjacent over my hypotenuse, it will stay the same for all these triangles, these similar triangles. And if we simplify that, do you see? Sorry, my handwriting isn't great. And that would be that. So let's put that into words, shall we? In a right angle triangle, if I've got an angle of 30 degrees, if we take the adjacent and we divide it by the hypotenuse, the ratio of the sides will always be square root 3/2. So if I create another triangle that has a 30 degrees, doesn't matter how big it is, it can be from here to the moon. But I know the ratio of my adjacent over my hypotenuse would be equal to square root 3/2. Now, what did they do with that knowledge? This knowledge for us, thank goodness, is in our calculators now. So we just press some buttons. But ask some people that's older than you, maybe somebody whose ID number starts with a 5 or a 6, and ask them about trig tables, if they remember trig tables. And I'm going to show you in a moment. This is a trig table. So if they go to an angle of 30 degrees, let's go to 30 because we were just working with 30. 30, the sine ratio for an angle of 30 is 0.5, which is just a half. We just saw that. And obviously we can use the table. You can go to 60. If it's 60 degrees and it is cos, that will also be a half. If we go to 45 degrees and it's tan, it will be 1. The ratio of sides will be 1, so it will be 1/1. Oh, that's interesting because it will be an isosceles triangle. So then they had to read what you just put into your calculator. They had to read off of the trig table. All right, now let's just quickly go and look at this thing. So let's just try and do this together. So if we have an angle of 30 degrees and we've got the opposite side, using trig ratios, we will be able to find the missing hypotenuse. So what we said in words, we're going to write that in a mathematical way. Well, we know when we had an angle of 30 degrees, if I divide the opposite with the hypotenuse, the one that we are looking for, I'll make that x, and this is my sine ratio, that is built into my calculator. So if we simplify this equation, I'm going to multiply both sides by x, like that. Now it's just an equation that I'm solving. This has nothing to do with what is trig. So then to get x by itself, it would be 10 divided by sine 30 degrees. So x is equal to 10 divided by sine 30, which is equal to 20. Now, I didn't really need my calculator for that because I know from the examples that we did previously, don't worry, you don't have to memorize these, but I knew that my sine 30 ratio would be 1 over 2. From what we saw above, not above, it's not above for you, but above for me, what we saw earlier in the video is that we saw if you add an angle of 30, the opposite over the hypotenuse will always give you this ratio if the ratio is simplified. So from here, I knew that 10 over something must simplify to a half. And this is some fraction knowledge that we all just love. And that would be 20. So I could figure that out based on the investigation that we just did. But thank goodness we have our calculators. And then we know that that side length over there is 20 when we add a 30 degrees and our opposite is 10 because we know what the ratio must be. Let's look at the next one. So if we are at an angle and I have the opposite and the hypotenuse, then I'm like, okay, wait a minute. The opposite and over hypotenuse means that we're dealing with the sine ratio. That's naming it. It's the sine ratio. We don't have the angle, but it's opposite over hypotenuse. If we simplify that, we see that's a half. Then we're like, oh, okay. So therefore, the angle must be 30 in order to have that ratio between sides. Do you have to have that memorized? No, because you can put it in on your calculator because you can't memorize it for every single angle. Let's say it was 31, 35, 36, 79. Every single angle will have a different ratio. And that is where the table came in. And thank goodness, that is where people who program your calculators come in. All right, now lastly, let's just quickly summarize this that you need to go learn for our sine ratio, opposite over hypotenuse, cos ratio, tan ratio, and there's just your SOHCAHTOA that I'm sure you've seen, just that little acronym to help you remember it. And now, where do we use trig? First one, I just put the link there from my Google search. Navigation, angles and distance in navigation, like just think about your GPS that you use all the time. Astronomy, I'm sure that's obviously there's different ways, but I just copied some of the highlights. Calculating celestial positions and orbits. All right, that's a good one. Aviation, height and speed of any flying objects. Don't know how you feel about that. What kind of flying objects came to your mind there? A marine biologist, and that has to do with finding the level of the light levels at certain depths in the ocean. That's how I understand that. And then I came across an interesting thread of people sharing where trig gets used. Engineers, they use it to calculate forces. So I'm just going to skim over it, calculate forces and stresses. And it has a lot to do with safety and stability. That definitely caught my eye when you're building structures like bridges, buildings and towers. So clearly the stability and safety is so important, and trig helps with them making sure that it is. Then electrical engineering and figuring out all sorts of things using trig functions. Let me just see what catches my eyes. They use trig identities to calculate phase shifts and frequency responses accurately. Okay. And then that's for optimal performance. Okay. And then also antenna design, determining beam direction, radiation patterns, and crucial for communication systems. That's a good one. All right. So electrical engineering. Trig is crucial in civic engineering, designing roads. Proper slope and drainage. That makes sense. The grade of the road must be carefully calculated to allow for safe vehicle travel, especially in hilly and mountainous regions. Elevation change, so think about your slope. And again, it's for safety and for efficient drainage and maintenance. We saw that. And then there's also just in aerospace, Trig is used to calculate trajectories, orbits, and launch windows for spacecraft. Cool. Launch windows for spacecraft and satellites. Very cool. And yeah, I'll also put that link in the description of where I came across that. And I'll see you in the next video.